we're gonna continue with our analysis. Let's say 73 now. All right. Yeah, I think what we can do is we will try and maybe run the actual job with the actual actual data. At least that way I'll just explain like one script at a time and then get some outputs, and then we'll just let this run.
Okay.
Because I'm not entirely sure, or at least okay, we can do.
It's about halfway, like, I guess. Right?
74, about 100 to go.
Oh.
Yeah, because because these are like in it starts at 1 and it's like 74. It's like 173 samples.
Yeah.
So it might so let's see. Okay, we're gonna do two things. We're gonna resubmit the job about generating files using more CPUs but different outputs and see if that helps. And then alright, so instead of making it output in a directory called process, I'm gonna make it output in a directory called let me make a new directory called job, because that way that's the only way I can know if it's working or not and how fast it's going. Sorry. So the output directory, maybe this one. Alright. So instead of using 700, we're gonna use, let me see how much is left of this all up. Because we are, I'm assuming the only ones that are trying to run stuff right now. Oh yeah, there's tons. Let me see, 75. That's 75. That's 150. That's 90. Okay. So this is assuming that we have about 400 that's being used up by Kelly, and then the Solar Lab has 2,000 gigabytes of RAM, right?
Yeah.
Okay. Okay, cool. Oh yeah. So I'll just leave it at 700. How many CPUs do we have?
No limit. Oh, 8. Wait,
No.
It's public.
So yeah, it tells you
Oh,
that 128. Okay, 128, and yeah, we might need to reduce the amount of CPUs that we're using for this. So Katie's already using 6 plus 6 plus 6, 18, 20.
Okay.
So we have 100 left, 108, sorry. So let's just use 50 CPUs.
Okay.
All right, and then guess second folder. Okay. Okay, so the first thing that we're going to do is going to submit this job. And then after that, we're going to see if we can work with, invalid directive. I think that was not supposed to be a space. Okay. The error was a space over there. All right, XQ user. All right, so that's running. So in the tests, let's see, jobs. All right, let me reload this. All right, we can double check this after like 10 minutes.
Okay.
And see. So the other thing that we're gonna do now is for the actual data. Let me just close this. For the actual data, we're going to try and run the first script. Pixie run, new data, Comethyl. Okay. why is this? Oh, it's alright, so 700. Yeah. So I think we should still be good for this. Alright. Wait, this is all pixelated stuff. Okay, so we're gonna try and run the first script. I think what I'm gonna do is I'll run it. Alright, so I'll comment out all the other second things. Or maybe, you know what? For the fun of it, I would just let it run. Yeah. All right. So what I was planning on doing was I was gonna do a test where I'm only running one script at a time by commenting everything else out. But I'm not gonna do that. I'm just gonna let it run.
Yeah.
Everything and see. Continuity. Okay. And see. It's called how far it goes. Because usually what happens is with Comethyl, if everything is good to go, like your scripts and everything are good to go, it should take like 24 hours to run it.
Okay.
Like from start to finish. But anyway, so I'll just submit the job, and then as it's making outputs,
Yeah.
we'll just be double checking and discussing those outputs.
Okay.
Yeah, some of those outputs are very similar. I think most of them are very similar to what Charles has in his tutorial.
Okay.
So the outputs are going to be familiar. It's just that the way I just designed this code is confusing in the beginning, but you should get it with time. I think the more time you do commit, well, I hope you appreciate.
Yeah. Yeah.
All right. Anyway, so let's. Okay, I'm gonna try and submit this job, but I just want to make sure everything is in order to go. So, all right. So the Pixie one. All right. So this is the Pixie one. Copy path. Let's double check that. Did you get an email about the job? Okay. CPU.
Yes. Yeah.
All right. So you see this thing?
Or the
here?
cancel job.
Well, not the cancel one. So this means, yeah. So if it's PD, means I know it means that your job is in the queue. Don't really know what the abbreviation means. And then this also tells you why your job is not running. So QoS group CPU limit means we are using the amount of CPUs are beyond the group's limit. So what I'll do is I'll cancel the job, and then I'll reduce the number of CPUs that we're using, and then I'll submit it again. So dispatch, Pixie. Let's see. Actually, let me. Oh, what did I do? Okay. 0.75. Okay. Let me just double check how many CPUs are being used right now in the lab. Cell lab. So 50 plus. Okay, plus 20, 70. Oh, okay, I see. All right. So let me just was off by like 1.
Oh.
We have 128, right?
Yeah.
Okay. So 58 plus 70 is like 129.
Okay.
So that was over the limit for the LaSalle lab.
Oh, okay.
So yeah, so I think this should work. All right. Okay, we're gonna SQ. All right. So because it's writing resources now, it means damn, that was gonna work. So why is it loading? Resources loading. Let me double check what's happening there. Huh. Yeah, I think this is the way they just designed Hive. So sometimes, even though we have 2,000 gigabytes on paper, they have to kick someone out so that I can get back my like the RAM I'm requesting. At least the way I understand it. Oh. Alright. Let me. Alright, let me try and reduce the amount of what's called amount of RAM and CPU to like 100. And this is like 50. Because we really want this thing to drop. S batch. Okay. Alright, SQ. Yeah, it's out of my control now. Pending. Alright, so just wait and see. So let's just double check on the samples that are running now. Oh, 90. Alright.
Okay.
Making progress.
So that's over halfway.
Yes.
Yeah.
That's over halfway. Let me see if the job is running in the. Yeah, I don't think this is working as well as I wanted to. S batch. Oh, sorry. CD. Alright, I think for the mini data, we're just gonna wait on the other run that we're doing. And then I'm gonna cancel this job that we submitted. This experimental job because it's not doing anything. It's just wasting our. Mini data. Oh. Wait. Did it actually start? Let me just double check something. Oh, okay. So our jobs haven't started running, I think.
They haven't.
Yeah. Is this the last email you got?
The last one was
The cancellation,
the
right?
one.
Yeah, so usually when the job starts running, like you see how this time you had job was blah 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 and it started running.
Yeah.
But for these jobs, we haven't received any email, so I think they haven't started running. Because if it's running, it's supposed to have an R. And then the time left for the job to finish is supposed to change each time you like do up. Like you see how on my on-demand session,
It is changing.
it is changing.
But yeah,
But for these two,
they're
it's not changing.
not. Okay.
Which is odd. But yeah. The benefits of having a mini data is you don't have to worry about scheduling. You just can run stuff like the same way I'm just running things locally. And then that way you can troubleshoot faster. So that's why, even though it takes time to make the mini data, the benefits of having a mini data is you can just run it locally either on the terminal or on your laptop.
Yeah.
And then that way you can brainstorm and troubleshoot code faster. Yeah. So, with that being said, I think the only thing we can possibly do now is, I guess, explain some code. Because this is in progress. The mini data is in progress, and let's see. I think, is there a way I can make this run? I don't think so. Right, let me just double check one more time. Yeah. All right. We'll just wait. Let me know if you get an email about the job running or at least starting.
Yeah.
We'll just go over some of the scripts. So import. All right. So let me open this on the side. Okay.
So were there two jobs that we're waiting on? The Make Mini and the Comethyl?
Yeah.
On. Okay.
Which are basically the jobs that are the reported jobs. So, oh, you know what we can do also? Just remember. All right, let's. It might just take some time, but what we're gonna do is, for each of the scripts, I'm just gonna be running them. Let me find another terminal. I'm just gonna open another terminal. I'm gonna run each of the scripts directly on the terminal. It's okay to do it this way because we requested we're in an on-demand session and we have requested computing resources specifically to you. But if you log in on your terminal, like directly, it was not advised to do it that way.
Oh, okay.
Yeah.
It's better to do it through this or the.
Yeah. Or either you can submit a job or you can do something like this. Yeah. Okay. I was gonna say my Hive is being slow for some reason. Anyway. Yeah. Let me change directory to this folder. And then repro pixie. All right, so I'm gonna try and run the first one, which is reading. All right, so yeah, so you see how in the script there's a message that comes up at the top. That's basically the message that you're seeing here. So what would usually happen, I think, when I mentioned and told you about the Comethyl standard output and errors, is the error log or the output between the two, I don't remember which one. It's the one that's going to have all this information about the script as it's running. I think it's the error one. Yeah, this one might have it. Let me just, yeah, we can always double check it later. But it's basically going to have, so how, like the way you can see this on your terminal, it's going to be like a text file that is this information too. All right. Let me open an example. I was contemplating on whether I should open an example or not. Let me look at a different project that I did. So BGW Comethyl output. So you see how you have the standard error and standard output?
Yeah.
And then the standard error or output will let you know script 00 is starting. Yeah. And then an error as to if something doesn't work out, error. And this was mostly in the beginning, but okay. Yeah, so this is showing you that it's starting and you get some warnings about some versions and the output directory. So you see how the information that you're seeing here is basically similar to what you'd see if you were to run it directly on the terminal.
Yeah.
Does that make sense?
Yeah.
Okay.
Like the step by step, like what it's.
Yeah.
Doing.
So the standard error. So if you were to troubleshoot anything, the first thing to go and look at. So remember how, like, for the for SnakeMake, we're looking at the log files.
Yeah.
So this is basically similar to log files.
Okay.
Is you're gonna be every time you do an analysis, you run something, you open this file so that you can see and look at the outputs, if everything ran properly or not, and then you can also just basically just look at the general outputs to see what was happening. So basically, in the beginning, for your script, it helps you load packages that are going to be used for different steps. The opt process is for helping with making arguments. Like, so in the script, you see how you have these different arguments, like the projects, the meta, the CITO, and the workers. The opt process is also just going to help you make those. It's going to help you be able to use that sort of language in an R script. Okay. And then it'll help you with validating the inputs that you have. And then if any of these steps are not run properly, then the script will automatically fail. So it sort of does all these checks in the background, and then it would then define your output. So output is going to be your project root. So it's going to be opt project root. So remember how we set the project root to be this in this case? So that's going to be the output of the pipeline, and then it's going to make another output called Comethyl output. So that's why I was saying we don't need to make an output right now because that's going to be automatically generated by the script.
Yeah.
And then within the Comethyl output, it's also going to make a step directory, and then it's going to take the file path from the pipeline root, which is this one, and then it's going to make another folder called CpG extraction.
Okay.
So at least what I've done, so this is slightly different from what Charles has, in that Charles doesn't have it organized in this way, such that you have a Comethyl output and an CpG extraction output. Because I just wanted to make it simpler such that if I wanted to look for something, I can find it quickly and have all my outputs be specific for each script that I have. So this first step of reading CpG files is going to be similar to reopen Comethyl. So it's basically going to be this. It's going to read in your Excel file, and then it's going to also read in your methylation files with the getCpG function.
Okay.
And what I did is I took the getCpG me function, or getCpGs, which is this one. I think there's probably more things to it. And then I wait. Okay. Let me bring the thing next to it. All right. All right, so this is here. Get CpGs is going to help you with getting the CpGs, like the total CpG, and it's going to help make a methylation matrix.
Okay.
The methylation matrix basically has your rows and columns as your sample information and the methylation information, like how much methylation you have for each CpG.
Okay.
Let's see. So some of these other steps that I have is basically to set, so annotation hub is used for the annotations, and it's basically to help to make a cache file so that it doesn't keep on reloading every time you start it. And then the param bicore parallel multi-core is to help with parallel processing.
Okay.
So when you specify the amount of workers that you're going to be using, you're going to be using like different CPUs at the same time. So in this case, we specified it to 4, so it's going to be using like 4 CPUs at the same time. And then for reading the metadata, so it's going to be data is equal to openread, OpenXL. OpenXL is the package that you use.
Yeah.
So like with all of these things, there's like a package and then the function that or the command that's from that package, and then how to use it. So the package is OpenXL, and then the command to open Excel files is read.xl, and then the Excel file is going to be related to this. So you see how you made the argument underscore like dash meta,
Okay.
like on this line 67. Boom. And then that's going to be your meta file. So that's basically the object that's being taken. And then for row name, it's going to be setting it to true.
Okay.
So let me just double check because I don't know if.
Okay, so this gives you the output as an Excel file, and this stage is like kind of.
So right now it's just taking it as an input.
Oh, okay, yeah.
So it needs it as an input so that it can use the Excel file to know. Oh, why?
Oh.
I got. Let me see.
Oh, is it because was this the old one? Is that why it's not? Oh,
No, I think it's. I don't know. Sometimes it doesn't work. So you just have to reload it. So yeah. So the first column is going to be the row names as long as you delete the
ones
information.
Yeah. Okay, so those are all true. Like, okay.
Yeah. So you set the names to true so that this part where you're getting these ones is going to be equal to like the sample IDs. So that way, it also has a check to see like if n rows is equal to 0, metadata is empty or is corrupt with some. So you make sure that you read in your Excel file. And then the next thing is you're going to construct a BSseq object. It's basically what has the methylation matrix in it. And so let's see, output unfiltered. So it's going to take the so this is for making the output file, the output for the unfiltered, because for Comethyl, the first part is you read in the methylation information, and from that you get, you also generate a text file that's going to give you like the coverage that you have, the sample, and so on and so forth. So basically it's an unfiltered BSseq object that you're going to keep. And then the next step in the script that I'm going to show next is once you have identified the sort of coverage you want to use, then it becomes like a filtered BSseq object. And then after that, then you can also then move on to like defining the region and so on and so forth.
Yeah.
So the first part is the unfiltered needs to be made, and this is the output directory, and I guess old working directory, and set working directory. So basically this is changing in between the directories that you have specified. So initially the project or root directory is this one. So like the intergen blah 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 George is the root directory, but where your cytosine reports are is not the same directory, right? So you need to set directory to where the cytosine reports are, and that's going to be out by this out cyto underscore directory. And this is also just basically specified by this argument dash dash cyto. And then once you have specified those things, then you're going to be able to run the get CpG, and then the core data is going to be basically equal to. So once you read in the data folder, it's going to be data. So now it's going to be now known as data. The Excel file is called data now.
Okay.
So core data is basically equal to data. And then, so because you have to write it in the specific way the function expects it to be, so it has to be core data equals data, because in Charles's function, it expects the core data. If it doesn't see an object called core data, like it's just like column data. I don't know why it's called that.
Specifically.
Yeah. So it's basically, so like he explains, like it's a data frame whose row names specify CpG reports to load into the CpG, and whose columns are traits and numeric values. So if it doesn't have that, you get an error. So I already did troubleshooting with this, and I had errors before. Okay. So basically now core data is that, and then the file for the output is going to be equal to that, because basically going back to the original function, the file is always going to be something unfiltered dot. That's going to be the file that's being made. So each time in Comethyl you get like a file thing, it's usually the file that's going to be created. And then the parameters for parallel processing are just going to be based on the argument for workers. So it's just going to be 4. So basically this. And then all the other parts are mostly similar to what Charles has. So the CpG totals is going to create a text file that's going to have all your CpGs. I think we can. Usually this first part doesn't take a lot of time. Oh, well, it's still running because it's a lot of samples. But I'll open an example for you so that you can see. So some of these, like the unfiltered BSseq.rds is yeah, I forgot what RDS stands for. What does RDS stand for? But it's basically an object you can only read on. It's an R data serialized. Okay. It's basically an object you can only open in R.
Okay.
So you'd need, so if you wanted to open, so for example, if you wanted to open this unfiltered BSseq object, you'd need to like start up R. Am I not doing anything? Okay. So you'd need to like start up R, and then, oh, okay, I don't have it here. Let's see. Okay, anyway, no, I will not do that now. Basically, I wanted to open the RDS object. We're not doing it now because you don't need to do it, because the information from the unfiltered RDS file is going to be in the text file anyway. But I can give you an illustration of it. Let's see. Sorry, let me just set it. I think. Do you know what time we started?
1:30.
I mean, like.
Oh, 1:20. Oh, from
the second time.
3:15.
Okay. So like 15 more minutes.
Sure.
Okay. All right. So yeah, anyway, so the information from this unfiltered BSseq, what's important is going to be the text file. And then the CpG total is going to be a PDF. So these are the first 2 outputs that you need to look at without question.
Okay.
I think I've never even opened this myself, to be honest. But yeah, we can try to look at it as an example.
Okay, yeah, and then the text file and the PDF about the CpGs it'll just be like just numbers, just
yeah. So stuff. I'm gonna open one as an example. Let's see. Where are we with our? All right, so 118. All right, cool. And that's still reading. Okay, cool. Oh, actually, let me double check the job.
Yeah, I still didn't get an email about it starting.
You haven't gotten an email?
No. Do you want to resubmit it?
No, it's at this point there's no point.
Okay.
Okay, something is running.
Oh, one is running.
Yeah, one is
Okay.
running. I don't know why this one is not running, to be honest, but one is running. Yeah, it is running.
Okay.
The time is changing. Okay, so yeah, I'm gonna open an example from a different project so that at least we discuss this. So, all right. So you see how for all the projects that I have for Comethyl, it's just going to be a similar structure, and it's going to be easier to follow. And then for the OP, like O00 CpG extraction, you're going to have a text file which looks like this, and then you're going to have a PDF which looks like that.
Oh, okay.
So we'll start off with the text file. I think I explained some of this when we did the video, but I can explain it in more detail. So for the text file, you have five columns, and then I used Rainbow CSV. Do you have Rainbow CSV, by the way?
I don't know. I don't think so.
Okay, you can go over
Here? On the sides?
extension. Sorry, the last squares. Yeah, and then you can search for Rainbow CSV. Yeah, and then you can basically install that, and that will allow you to open the text file easier because if it's not if it's not colored in any way, so
it's just hard to read.
Yeah, it's hard to read.
Okay,
so the first column is going to be your coverage. If you wanted to open the one I opened, it's going to be in what's it called?
Yeah, I'm under the
Grow wall.
So you're in grow wall.
It's not, yeah. So find grow project. Yeah, and then find 2025 BGW, the first one, and then open Comethyl output, then open 00 CpG extraction, and then open the text file.
Yeah.
Yeah, so the first column is basically going to be your coverage. The second column is like the percentage per sample, which is like the percent of the sample that we want to target or that has coverage in that specific, percent of sample that has coverage for that specific number that we want. And then n sample is going to be equal to the number that equates to the percent of those samples. And then n CpG per million is going to be number of CpGs in millions. And then per CpGs is, I guess, maybe percent of CpGs that are being used, I suppose. Yeah. So, for example, I'll just start from the bottom because it makes more sense. So, 100%, if you wanted to say, okay, you wanted to make sure that you had coverage for, sorry, is this? Yeah. So, for 100% samples, that means you have 48 samples. And then that means you have 29 million CpG covers.
Okay.
And then that means you're using all your CpGs.
Okay.
So as we start going for more and more coverage, the number of CpGs that are being covered at a higher coverage for most samples starts to decrease.
Okay.
So usually I think the default that I work with is 3x coverage, 3x coverage in 0.75. Can you please close the door? Thank you. So what we usually work with for default is like 3x coverage at 0.075%, and that's going to equate to like taking 36 samples, and that means we have 25 million CpGs that we're taking approximately.
Okay.
And then that's about 80% of your CpGs in total.
Okay.
So the goal is to try and include as many CpGs as we can at a decent enough coverage. So usually 3x works for me. But going back to Charles's tutorial, which is the origin of this story, let's see, does he specify? Oh yeah, so we look at the coverage and the per sample ratio to try and be able to know this value that we're going to use to filter CpG and generate this filtered BSseq object.
Okay.
All right. So basically, my second script or to or let me see. So the second script is going to be O1. It's going to be filtering CpGs, and then I think the filtering CpG that I used is like 3x 0.75, and that would give me a certain number of CpGs. So if it was the case for this project at 3x, like I said, you'd be getting like 25 CpGs. So we'll see what we have with our data. Either 2x or 3x for this first part.
Yeah.
And then the next part is the O1 script. Okay, let me just double check if anything is run. So this is still going. Ooh, all right. Yeah. One parallel job did not deliver a result. Yeah, I don't entirely know what this error means. This is actually the first time I'm seeing something like this. So error in reducer dot value cache. All right, I'll see if let me double check if I get the same error with the job, and then if I do, then we'll troubleshoot it. I'll just let it be for now, because usually with the with the main analysis, I never run it here, but I just wanted to run it here as an example, but it gave us an error of some sort. So I'll see if the actual the other job is running now. The make mini data. Did you get an email? Oh, it's supposed to send me. I don't know. Maybe I made a mistake somewhere. Let me see if I got an email.
Yeah. Okay.
No, I didn't get anything.
No. Okay.
Yeah. Anyway. So yeah, I will. Let's see. Okay, let me actually double check and see if there's anything right now in the folder. Yeah, I don't think there's anything yet. Alright, there's nothing. And then let's. Ooh. Why is it in red? Okay, so it's still going through stuff. Okay, because it's new. Did I delete it? Alright, I think I had deleted a file like this before, that's why it's coming up as deleted.
Okay.
But no need to worry about it now. Anyway, so it looks like it's still running. Read Bismarck parsing. Alright, so this is the part that failed. So if this fails as well, when this script is running, we will troubleshoot this and see what might be the issue. So I was going to move on to explaining the next script, which is this one. Alright, so the purpose of this is to filter CpGs from the unfiltered BSseq objects using user-defined coverage and sample presence thresholds, and then groups the retained CpGs into groups. So this is going to be similar to this part. So first, we're going to filter CpGs. At some point, you see code similar to this, and then you're also going to define regions using the getRegions function. And the regions function is going to say, I think maximum gap. Let's see. Specifying maximum number of bases between CpGs to be included in the. So maximum number of bases to be included between the CpGs is 150 base pairs. So the minimum number of CpGs you need to make a region is 3. So that's the number, that's n equals to 3. And then the maximum gap that you have between those CpGs is 150 base pairs.
Okay.
So that's what you're going to use to make regions. So going back to O1 filtering CpGs. So like the other script before, it's going to tell you when it's starting. It's going to list out the packages. A lot of it is very similar, like the arguments. So let me also go back to, because some of the arguments might be different. So the input RDS file is going to be the unfiltered RDS file. So that's what's used. RDS file is what's used computationally, but usually for inspection we look at the text file. Yeah. And then it'll validate and see if there are any errors with any of these files, and then it'll make a cache directory. And then for the pipeline output, it's going to be Comethyl output. It's going to make a new folder called O1 filter regions. Percent label. Let's see. First sample. Okay, all right. So this is to do with the first sample, but I'm not entirely sure why it's there now. Oh, okay. All right. So the percent label is going to be used to make a new directory. So because with Comethyl, like there's so many things you can change. You can change the coverage. You can change 2x coverage in 75%. You can use 3x coverage in 75%.
Okay.
So what I then decided to do is I would make a directory for each of those outputs so that I can know what it looks like moving forward. So for example, in the actual pipeline, what would end up happening is it would have, so for example, in the filter regions, when I use 3x coverage for 75%, it's going to make a directory that's like cov3 7-5 PCT. That would automatically tell you that the coverage that was used was 3x and it was, it was 0.75. It's important because sometimes you might change some of the settings. So this is basically what's being done here, and it's making that extra directory that's needed that we're seeing over there. And then for variants, the variant directories are related to the new method we added to doing Comethyl. I think I can explain that more clearly when you look at the script that deals with those variants, but I think we'll just leave it for now. And then once it's done, so let's say oh, I guess, okay, no. I thought it was referring to something else, but I think for now, this variant directory is just related to the version that was used for coverage. I was thinking about something else that is in the script ahead. So then it'll just spit out a message that's telling you, okay, this is the output directory for where you're going to get your data. And then for the unfiltered BSseq object is going to be the argument plus the input RDS. So that's going to be equal to this. This is going to be your input RDS. All right, so that's our timer. All right. Do you want to take a break now and we come back?
Yeah, sure.